In today's lesson, we are going to look at choosing the right method. Now, there are multiple different trig formulas or ratios or laws that we've looked at, so we want to go through some steps to help us figure out which method is the right method for a given situation. So we're going to go through a little flowchart. We're going to take a look at kind of what we can look at or what we can look for to help us figure out what to use. So the first thing we want to do is check, do we have three pieces of information? If yes, great, we can start going through and solving. If no, then chances are we probably want to check again, and relabel or reread the question to make sure we have enough information. So if we do have three pieces of information, which is generally enough to use any of these laws or ratios, then we can start solving. We then want to check first, is there a right angle? If there's a right angle, and in word scenarios it might be indicated by asking for the height, mentioning 90 degrees, buildings or structures, right? Any mention of anything like that in a word scenario generally means there's a right angle, right? Or we're going to assume that it makes a right angle, right? Talking about the height of something to the ground, right? That height and the ground make a 90-degree angle. So if we do have a mention of a right angle, or we see clearly in a diagram that right angle, that square, then we can use SOHCAHTOA, right? So the sine opposite over hypotenuse, cosine adjacent over hypotenuse, tan opposite over adjacent, or the Pythagorean theorem, which again we are referring to now as the sum of squares. Same principle though. So if there's a right angle triangle, use your right angle trig, SOHCAHTOA, sum of squares. If no, then let's look again and let's see what information we have. Do we have an angle and its opposite or partner side? So again, the angle and the side across from it, or the side opposite of it, do we have that information? If we have that information, then there's a very good chance that we are using sine law, right? Sine law requires a full pair, or the pair of an angle and its opposite side. So if we have that information, then chances are we are probably using sine law. If we don't have that, then let's check again. So if we don't have that angle and its opposite, let's check again. And our last hope is having either all three sides or side angle side, that sandwiched angle. And if we do have all three sides or side angle side, then we can use cosine law, which is our third option. If there is still not enough information, or we still don't have one of these, then check again, reread the question, make sure we've labeled everything properly, or maybe we missed something. Maybe there's a small calculation we can do to find some of the missing information. Maybe we can use the fact that all angles in a triangle add to 180 to help us find missing pieces of information, right? So if we get to the very end of this flowchart and we still don't have a correct method, then maybe we missed something, or maybe there's a small calculation we need to do in order to get that missing, or in order to find the correct formula or ratio or law to use. So in choosing the right method, right, when we're dealing with word problems, what we want to deal with, or what we want to do, we want to first draw a diagram, right? We want to draw a diagram to help visualize the information, to help visualize what we're looking for. So we want to draw a diagram. We then want to use that flowchart to determine the most efficient way to solve the problem. Because again, we mentioned before, the sine law can be used even in right angle triangles. However, it may not be the most efficient because it is a longer formula, it is a longer law or longer calculation. So we want to make sure we're being the most efficient. So that would basically be using the first correct formula that we come across with that flow chart. From there, we can set up the solution and solve. So what we're going to do, we're going to look at 3 examples. I'm going to go through and help you draw out the situation, because that is usually the hardest part. From there, I will let you try to figure out what ratio or law we need to use and then calculate it. So I'll give you the opportunity to pause the video, and then we'll come back with the full solution. But I will help you draw it out first to give you an idea of what we're looking at. So in our first example, a distress signal is received from a ship that is north of 2 ports. It is 21 kilometers from an eastern port and 17 kilometers from a port located to the west. The east port is 24 kilometers directly east of the western port. Makes sense. At what angle should the ship head in order to dock at the western port? So let's draw out our information here. What do we have? So we've received a distress signal from a ship. Let's draw a little boat here, a little sailboat. Our person's in distress. We have a western port. Usually they have like little things that you can tie your boat to. So that's our western port. And we have our eastern port. Let's say there's a little tower there. That's our eastern port. So again, I'm not too worried about how accurate my triangle is to the actual situation, right? I'm not drawing really fully the points. The idea is that we're just kind of drawing out where things are located or where things are meant to be located based on this question. So it makes it a little bit easier to visualize. So we do know that the ship is 21 kilometers from the eastern port, 17 kilometers from the western port. And again, if you need to reread the question to highlight information, that's fine as well. We know the eastern port is 24 kilometers east of the western port. Now we want to figure out what angle the ship needs to head in order to dock at the western port. So if they're traveling, we want to figure out what angle they need to head. And something that might help is kind of like a compass rose, right? North, south, east, west, to help us figure out what angle we need to head in. So generally speaking, we know we're going to be heading in the southwest in this kind of general direction. Looking at the compass, we're looking at heading in this direction, so we're looking for this angle. So in our case, we might have to add in some extra information here to help us figure this out. Because what we can do, if we're trying to figure out that angle, or from a vertical line down, we're looking for this angle here, because then that would be how many degrees west of south. But before we get to that, right, you might have to use some other information first. So try to find some information first before going on to that right angle triangle, right? I'll give you a hint, that right angle triangle is not the first step, right? Which kind of makes sense because we don't have enough information with dealing with just that right angle triangle. So try to ignore that first, think about what information you might need to solve for, and then work from there. So again, I will give you the opportunity to pause the video so that you can try this on your own. So coming back to our question, you should have first determined that you had to use cosine law. We were given 3 sides, so the only thing we could have really used was cosine law. So now, that may have been easy. Which angle to find may have been tricky, but as long as you knew you had to determine an angle using cosine law, that's at least a start, because that's the first step. So because we're trying to find the angle that we're heading in, you may have decided to find this entire angle here, which wouldn't be terribly wrong, but in order to find a direction, we want to be a little bit more accurate. We're not trying to find the angle between the two directions. We want to find out what angle they need to head. So what we've done is we found the angle. Find the angle over here between the boat and the eastern port. By finding that angle of the triangle, that gives me enough information then that if I draw a straight vertical line down, assuming, like again using a compass, I can find this angle in particular. So specifically that angle. Oops, I got rid of my entire boat. We can find this angle in particular by drawing a right angle triangle, understanding that we have this angle, the 90-degree angle. The missing angle is 180 minus 90 minus the 58.6, which gives us 31.4. So now we can say that the ship needs to head 31.4 degrees west of south. So if they have their compass directly south, and then they're turning it 31.4 degrees west, that's the angle that they need to head in. So again, it just gives us a little bit more direct information, so especially in terms of where we're heading. Taking a look at the next question, a ladder 5 meters long leaning against a vertical wall makes an angle of 65 degrees with the ground. How high on the wall does the ladder reach? So again, this one might be a little bit more straightforward. Right, we have our ladder. Right, we have our person walking up the ladder. Or surfing up the ladder, who knows? Walking up the ladder. The ladder is placed against a wall. So placed against a wall, we know that the ladder is 5 meters long. So we know that the ladder is 5 meters long. We also know that the ladder makes an angle of 65 degrees with the ground, and we want to determine how high is the ladder touching the wall, or basically what is this height here, or that overall height. So again, I'm going to pause the video. I'm going to let you try to determine what type of law or ratio to use. I would think that this one is a relatively straightforward one, but again, I'm going to give you the opportunity to pause the video and to try to solve this on your own. So coming back to this question, hopefully you realize that the wall and the ground form a 90-degree angle. Because we have a 90-degree angle, that means we have to use one of our trig ratios. So that's where we label our 3 sides: hypotenuse, opposite, and adjacent. From there, hopefully you determined that we needed to use the opposite and hypotenuse. Those are the sides that we're dealing with, which again tells us that we should be using the sine ratio, not the sine law, the sine ratio. We plugged in our information, we solved, and we should get that x is equal, or the height that the ladder reaches to is 4.53 meters. So again, hopefully this was relatively straightforward in terms of identifying that we did have a right angle, and that tells us that we have to use one of our trig ratios. So going back to labeling those 3 sides and so on. In our final example, Lena is in a bicycle race. In the first leg, she rides 12 kilometers from Riverside to Danton. Then she turns and rides 17 kilometers to Humbersville, making a 74-degree angle from the first leg. The final turn heads back to Riverside. What is the total length of the race? So, again, we have Lena on our bicycle. So, we'll draw our quick little bicycle. So again, we're very accurate in our drawings. On the bicycle, and the first leg she rides to Riverside, which is 12 kilometers, or from Riverside to Danton, sorry. So again, 12 kilometers from Riverside to Danton. She then turns and rides 17 kilometers to Humbersville, making a 74-degree angle from the first leg. Then she turns back home and heads back. We want to know what is the total length of the race. So we want to know what is the total distance. In this case then, we need to figure out this missing side. So again, I will pause the video, give you an opportunity to determine what type of ratio you need to use. So coming back to this question, again, hopefully you determined that we had to use cosine law. Again, there's nothing here that tells us it's a right angle triangle, and based off the information that we had, we didn't have a full pair anywhere, but we did have SAS, or the sandwiched angle or side angle side. So that gave us enough information to help us find or determine the missing side length. We made sure that when we plug things in, hopefully that the side we were looking for was paired up with the angle we're looking for in terms of our formula. We plugged everything in, we found that that missing side was 17.9. Then, because the question was asking for the total length of the race, we needed to add up all our sides and find that the total length is 46.9 kilometers. So again, in these three examples, we didn't really cover sine law. So again, if you do want to review that, please make sure you go back and take a look at the sine law lesson. But again, the main thing here is determining or being able to draw out your scenario or the problem and determine what type of law or ratio you would have to use in order to solve it. So again, you can always refer back to that flow chart or refer back to the specific lessons to kind of strengthen your understanding of the different laws and concepts.